Good day, ladies and gentlemen. My name is Savik. By God's grace, I'm the owner of Brainpoint Academy. I'm also a medical student. So today we shall commence our teaching. And before we commence our teaching, please, I would like you, after watching this movie, you like me, you subscribe to my channel, and also comment on the comment section. So why is it necessary for you to subscribe? The reason why it is necessary for you to subscribe into this channel is for you to be receiving current updates from my channel, from my academy. So please endeavor to subscribe, like, and also comment on the comment section. Please also try to share this video into your various platforms where your friends can be located. Are you with me? So we shall commence our teaching, and our teaching will take our topic from physics. Are you with me? So please remain connected. What I keep on telling my students here is it takes connectivity for one to connect very well. So please pay attention as I start my teaching. Are you with me? So pay attention. So our topic in today's class is coming from physics, and which says motion. Are you with me? So we shall be looking at motion and know what you can understand from motion. So please remain connected. Okay? So what is motion all about? Researchers tell us that motion is the change in position of an object with time. So motion is the change in the position of an object with time. So if an object moves from a point A to point B, are you with me? So the object have said to cover what we call motion. So motion is the change in the position of an object with time. Are you there? So now the change in position of an object with time can be occur into various forms. Are you with me? And that is what brought types of motion. Okay? So we shall be looking at the types of motion into 4 perspectives. Are you there? So what are the types of motion? So we have 4 basic types of motion. Number 1, we have linear motion. Linear motion. What is linear motion all about? When we talk about linear motion, we are actually talking about the movement of an object from one point into another point without rotating. So the movement of an object from a point A into point B, are you with me, without rotating, is what we call linear motion. So when linear comes to your mind, it means on a straight line. So the motion of an object on a straight line is what we call what? Linear motion. Then I want to speak to you in advance that linear motion is also known as what? Translational motion. There is a particular place in JAMB past question where they ask what is another name for linear motion. They gave a lot of options. But if you see an option that carries translational motion, go with it. Are you with me? So that is all about concern linear motion. So the second type of motion is what we call rotational motion. Are you with me? So what is rotational motion all about? So rotational motion, just as the name implies, is the motion of an object on a cyclic path. So the motion of an object in a circle is what we call rotational motion. Are you with me? So rotational motion, in other words, is called circular motion. Are you with me? So when an object turns around, we say that the object has undergo rotational motion. Are you with me? So please take note, and take note very well. Okay? So what are the practical applications of rotational motion in our society? What are the practical applications of rotational motion in our society? Okay? Now, so we have so many applications of this type of motion in our various places. Take for instance, the movement of electric blade of electric fan is rotational in nature. Are you with me? So the movement of electric fan, the electric blade of electric fan, are you with me, is rotational. Are you with me? Now, of course, all of us have electric fan in our places. Okay? So when you look at how that electric fan, when you look at its blade, the way it functions is rotational in nature. I hope all is well. Now, another example of or another application of this type of motion in question here is uh, the movement of a wheel of a moving object. The movement of a wheel of a moving object is also rotational. Are you getting me now? Now, when you take a careful observation on how the wheel of a moving object, okay, works, you find out that the wheel is rotating. Are you getting me? So that is how it is applied here. Okay. Now, another application of this type of motion here is this. Now, researchers tell us that Earth rotates around the sun. Are you with me? Earth rotates around the sun. So the rotation of Earth around the sun is also one of the applications. Now, from the geographical analysis, we found out that the rotation of Earth is what brings about day and night. So Earth can rotate. So the rotation of Earth around the sun is also one of the application of that type of motion. Are you with me? Now, we have so many of them, but let us stop here for the because of other types. We need to look at other types also. Now, see, for the exam purposes, sometimes they can ask you the movement of Earth's planet around the sun or the rotation of Earth planet around the sun is example of what type of motion. Are you with me? So please, when such question is given, please go back to what I said concerning rotational motion. So the answer is rotational motion. I hope all is well. Good. Now, sometimes they can ask the question in this dimension. They can ask you, motion is rotational under what condition? Motion is rotational under what condition? Are you getting me now? So when such question is given also, are you with me? So you begin to look at the applications I've given. So from the applications I've given, you can then trace your answer. I hope all is well. Good. Now, permit me to enter the next type of motion, which is what we call vibratory motion or oscillatory motion. If you don't call it vibratory motion, you can as well call it what? Oscillatory motion. Now, let us know when motion is vibratory. Are you getting me? So, when do we say that motion is vibratory? Now, motion is vibratory under this condition. Now, a vibratory motion is a type of motion, are you with me, that occur to and fro. So the motion that occur to and fro is said to be vibratory in nature. I hope all is well. So motion is said to be vibratory, or motion is said to be oscillatory when it moves to and fro. That is, an object that exhibits this type of motion must move to and fro. Are you getting me now? That is, when you move, you come back. When you move like this, you come back. I hope all is well. So that is when we say that motion is vibratory. I hope all is well. Now, what are the practical applications of this type of motion in our places? Because that is where problem lies. What can we see in our place and we say that this motion is vibratory? Are you getting me? So what are those things? Now research has pointed out some dynamics, has pointed out some things in our places that indicates vibratory motion. What are those things? Number one, good. The movement of bells. The movement of bells on a spix. The movement of bells on a spix is vibratory. Now, how is this so? Now, when you look at how bells move on a spix, it is vibratory in function. Are you getting me? So they do like this. They do like this, how they function. This is how bells move on a spix. Are you getting me? So the motion of bells on a space is also vibratory in nature. I hope you are with me. Good. Another application of this type of motion is this. That is number two. The beating action. The beating action of mammalian hearts. The beating action of mammalian hearts is also what? Vibratory. That is when you touch your heart, okay, the way your heart beats is vibratory in form. Are you getting me? So it is due to this periodic beating that makes heart to be an organ that pumps blood. Are you getting me? So anytime your heart stop beating in this way, it means that you are no longer living. I hope all is well. So the way your heart beats is a practical application of this type of motion. I hope all is well. Now, not only that, even theory has also pointed that the motion of a simple pendulum, the motion of a simple pendulum is also what? Vibratory. Are you getting me? All of us, this is a common practical analysis we have done in our various labs. Okay? So when you look at how pendulum bob oscillates, when you look at how it oscillates, it shows that its motion is vibratory because it goes to and fro. It goes to and fro. Are you with me? To and fro. To and fro. So its motion is periodic. That is why it is one of the applications of this type of motion. I hope all is well. Good. We still have other applications, but for the sake of time, let us move to our next type. I hope all is well. The next type of motion we're to look at in this segment is what we call random motion. Everybody say random motion. Now, I want to speak to you in advance that if you don't call this random motion, you can as well call it an irregular motion. Just as the name implies. What do you understand by random motion? Let us look at its meaning. Are you with me? So a random motion is a type of motion that moves in an irregular direction. Are you getting me? So an object is said to move randomly when it moves in an unspecified direction. I hope all is well. So the movement of an object in an unknowing direction, in a haphazard manner, is what we call what? Random motion. I hope all is well. Now, can we see any application of this type of motion in our places? Yes. The answer is yes. Good. Now, what are they? Number one, researchers tell us that the motion of a gas molecule, the motion of gas molecule is random in nature. Are you getting me now? So whenever you see how gases moves, okay, let's assume that you have oxygen, you have fluorine, you have nitrogen. The three gases you have mentioned now are found inside a container. Are you getting me now? So when you subject heat under the container where they are found, you find that motion will begins. Are you with me? So the three gases, they will begin to move randomly. Are you getting me now? So the motion of a gas molecule is one of the practical application of this type of motion we are discussing here. I hope all is well. Now, another application of this type of motion is this. Okay? The motion of smoke particles. The motion of what? Smoke particles. When you look at the way smoke moves, when you go to chemical industries or when you visit our homes, for those that use charcoal put fire to cook, so the smoke that is coming out from there, the fire, are you with me? You find out that it is not moving linearly. It is not moving linearly. It moves anyhow. It moves to anywhere it sees space. I hope all is well. So the way smoke moves is random in form. It doesn't have direction. It moves irregular. It moves in a haphazard. Are you getting me? So the direction of its motion is yet to be specified. I hope you are with me. So please pay attention. Okay, we have another hidden application. That is when you look at how footballers moves in a football field. Are you getting me? So they move randomly. Okay, the movement of football players in a football field is also one of the practical application of this type of motion. I hope you are with me. So please pay attention and pay attention very well. Are you there? Good. Now, These are the examples of each type of motions we have listed above. Okay, then before we shut down this class, I want to speak to you in this way. Okay, it is possible that one object can exhibit two type of motion at a go. It is very, very possible. Are you getting me now? Take for instance, this particular statement has been given as a question in one of the subsequent years, in one of the years JAMB. Okay, JAMB has asked question based on this statement I have made mention of. Okay, it is possible that one object can maintain more than two type of motions, more than one type of motion. Are you with me? Take for instance, what are those motion one object can maintain at a go? Number one is a linear motion, which is translational motion. Number two is a rotational motion. Are you with me? So take for instance, when you see a motorcycle that is set in motion, okay, so as the motorcycle start moving, it moves straight. Okay, so the tire of the motorcycle will maintain translational motion. Are you with me? So each tire will maintain translational motion. Are you getting me now? But when you look at the wheel of that motorcycle, you find out that the wheel is rotating. So the tire of that motorcycle will maintain translational motion. That is one type of motion. Okay, but the wheel of that motorcycle maintains rotational. It keep on rotating. I hope all is well. So now to conclude, all moving objects maintains, they cover more than one type of motion, and the motions they cover, the motion they exhibit when they are set in motion include rotational motion. Two is a translational motion. Are you with me now? So when such question is given, please know what you are going to answer. Are you there? So this class stop today. We stop here at this particular time. Are you with me? We stop here. Are you there? So please, if you find this teaching very interesting, can you just like, subscribe to this channel, and also comment on the comment section. Why is it necessary? I say this before I comment this teaching. Why is it necessary that you must subscribe to this channel? Why you must subscribe is this: when you subscribe, you keep on receiving regular updates from this channel. Are you getting me? So God bless you. I believe that this channel will find it very, very important. It will help you. It will take you a long way. Are you with me? Depending, irrespective of any exam you are going to take, this channel will give you what it takes. Are you getting me? So you are not the first one, you are not the second. So we have done this for several years, and many are giving testimony. Okay, so please do what I ask you to do. Any question regarding to what I have said, what I have taught, you are free to ask me. Okay, drop your question on the comment section. I will attend to you as easy. Okay, good day. Bye bye.